Okay, we're going to talk about the quadratic functions uh, portion of 2.1. Take out that 2.1 quadratic note, well, the 2.1 linear and quadratic note packet, and then there should be some slides. Look similar to this on there. So quadratic functions, we know a bunch of this stuff already. Number one, quadratic function is a function with degree 2. X squared. Standard form of a quadratic function is ax squared plus bx plus c. We use the quadratic formula then, which is this equation set equal to 0, solve for x. Those are the x-intercepts of a quadratic equation, which gives us our quadratic formula. Parent function, y equals x squared, graph of a parabola. You just worked with that with the 2 graphs, and we also worked with it in section 1.3 with all the different graphs for the parabola. Vertex at 0, 0, opening upward, reflected, the reflection of itself over the y-axis. It's the same thing. Even function is what I meant to say. Okay, so something that probably is a little bit of review, but the vertex form of a quadratic equation in the y equals a times x minus h squared plus k, where the vertex is at h and k. Remember, this moves, when we do it inside the parentheses, that's going to move us right or left. Outside is going to move us up or down. So if we're talking about the graph of y equals 3 times quantity x plus 6 squared plus 5, the x plus 6 means 6 left, and the plus 5 means 5 up. So remember, if we're talking about on a graph, we're going to go plus 6 is 6 left, because that would be x minus negative 6. That's how we get the plus 6. So move yourself 6 left, and then the plus 5 is 5 up. So the transformation point would be here. The 3, remember, that's a vertical stretch. I'm going to make it go up quicker, so zoom up and zoom up. Oh, that's a good looking parabola there, let me tell you. So this is going to be our main focus for this section. Describe how to transform the graph of f of x equals x squared into the graph of f of x equals 2 times x minus 2 squared plus 3. So my vertex is at h and k, which would be at 2, 3, which means how are we going to transform? Be 2 right, and we got 3 up. And then my 2 out here would be a vertical stretch of factor of 2. And remember, we said we could just call that, it's going to be much narrower. And we could see that on the graph. Main thing here, 2 right, 3 up, opening up, factor of 2. We already did this when we did our transformations. First one says if we're just talking about ax squared, if a is positive, positive means to open up. We have a minimum value. If a is less than 0, that's going to be negative. That's going to mean that it's opening down. Okay, this is probably the most important thing we have going on today. Write an equation for the quadratic function whose graph contains the vertex and the following point. This is similar to the homework problems 39 through 41, and there are other types of problems that are going to come up with this as well. So we're going to start with y equals a times x minus h squared plus k. And what we have here is 1, 3 is an HK, and then 0, 5 is a XY. And much like if you had y equals, or given 2 points, calculate the slope, find the equation of the line, you use one of those points to find what's missing in a linear equation. We are going to plug in 5 for y. We are searching for a. X is 0, h is 1, k is 3. So all I've done is plug, 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 and plug. And when we solve this, 5 equals a times negative 1 squared plus 3 minus 3 minus 3. 2 equals a. Negative 1 squared is 1, so we don't have to really worry about that. So my final answer here, what is the equation? Y equals 2 times x minus 1 squared plus 3. H and k clearly visible. The value of a is what you solve for with this other point. You can't just assume that a is going to be 1. So that's how, given the vertex and another point, you can find a. What would this look like on a graph? 1, 3. 1, 3 is here. And then 0, 5 is up here. Well, I have an axis of symmetry. I have another point. We go up, and we're good to go. So our minimum value is going to occur at 1, 3. Our minimum, or at x equals 1, y equals 3. The minimum value is 3. And then when they ask you for the axis of symmetry, the axis of symmetry will always pass through the vertex, and that's on the value of x. So the axis of symmetry here would be the line x equals 1. So in terms of, we have a max or min would occur at the x-coordinate, and it is the y-coordinate, and then when we ask about an axis of symmetry, it's going to go through the vertex at the x-coordinate. Second thing in this lesson has to do with the vertical free fall motion. We have an equation for position s at time t. G stands for, it's really the gravity. When we're dealing in feet per second, we're going to be dealing with 32. If some of your science classes, these are usually preloaded for the gravity. Negative 1/2 times 32 is negative 16 t squared plus v naught of t plus s naught. V naught is initial velocity. How hard is an object moving when it's flung or dropped or whatever the case may be. S naught, initial position. And then when we use the 9.8 in meters per second squared, we're talking about a position equation that looks like, I think most of the science classes actually use not negative 4.9, they actually use negative 4.91. For our purposes, we're going to use negative 4.9. Half of 9.8, negative 1/2 times, when I plug and chug, t squared plus v naught t plus s naught. So those are the two equations. When you're doing these problems, and then the velocity equation is right here. Again, one of these two values in here, v naught initial velocity. How fast was it when it was released? If you're doing these problems, if you're on section 2.1, if you flip back a couple of pages, there's a large box that has all this information in your book as well. So if you didn't get it all written down right here, you have it in your packet, and it will also be in your book. So we're going to do a problem with this. The Sandusky Little League, that's in the town of Sandusky, uses a baseball throwing machine to help train 10-year-olds to catch high pop-ups. It throws the baseball straight up with an initial velocity of 48 feet per second from a height of 3.5 feet. So here's what I see. I see initial velocity, v naught. I see initial height, s naught. I see we're dealing in feet per second, which means we are going to use the equation that deals with negative 16 t squared plus v naught times t plus initial height is 3.5. So we have an equation. So when it asks to find an equation that models the height of the ball t seconds after it was thrown, that's what this means. The position at time t. How high is it at time t? T is in seconds. What is the maximum height the baseball will reach? How many seconds will it take to reach that height? So I'm going to grab my trusty calculator. You should do the same. And we're going to type into y equals, because we can do all this on the graph, into y equals. I'm going to type my negative 16 t squared plus 48t plus 3.5. And when I graph that guy, I'm just going to zoom standard, see if it works on this case. Oh, Zoom Standard doesn't work. What? Oh, this is a mess. Well, we got to go to the window. Check some things out. X-mins, if we think about our x's are time t. So I'm going to go from time 0. I'm actually going to go from -1 so I can see it. -1 to, I don't know, how long is a ball in the air if a 10-year-old's catching it? Hopefully not too long. Let's go 10 seconds, counting by ones. Y minimums, that's how high is the water mama. If I go from 0, well, let's actually go from, let's go from -5 feet, 5 feet under to, how high does a ball go? 60 feet? I don't know. And we'll see, we'll go by 5 and we will graph. So my quadrant 1 makes sense for my domain. My domain is how long the ball is in the air. It looks like from time 0 to maybe time 1, 2, 3 here is how long the ball is in the air. And then how high is the ball will be the maximum here, which I think our calculator will also do for us. Second and trace brings us our calculate. We are going to calculate a maximum value. I need to get myself to a left bound, and you can watch the thing tick away to see where you're at. Here comes my spider. I need to get to the left of my max, or the calculator doesn't know what to do. Enter. And then I need to get to the right of my max. Right bound. I'm to the right of it. I'm good to go. Enter. And remember, what it's going to do is it's going to tell you the highest point in between those two values. And it gives it to me as 1.5, x is 1.5, and y is 39. So what is the interpretation of this maximum? At 1.5 seconds, it's as high as it's going to be. And how high is it going to be? 39.5 feet. So we would say at time equals 1.5 seconds. And the height, which is height at 1.5 seconds, would be equal to 39.5 feet. Incidentally, how could we figure out what time it hits the ground? Run back over here. I think we have a button that will do that. I could calculate. I'm going to calculate the 0. Hey, the 0, that's an x-intercept. Hey, the 0 is also the root of the equation. Holy cow, have we said that? Left bound. Need to be above it. I went below it. I did terrible things. Scrolling back up, I can see my y's are still negative. I got a little bit there. Now I'm above it, so I'm going to go left bound. And now I'm going to go to below it. And I'm below it. Enter. And tell me the 0 that's in between those two values. And I'm at, this is calculator error, that's a number 0, -1 times 10 to the -11th, and 3.07 seconds. So the ball has been in the air 3.07 seconds. So when little Johnny misses the pop-up, it's going to hit the ground 3.07 seconds later. And there you have an example of a throwing problem. Oh, the last one I was going to do, it went away. I wanted to do number 56 from the application worksheet. Let me see if I can find the application worksheet. 1 second. Okay, grab your application worksheet if you haven't already done so. And so these are actually out of your book, and you'll be able to, this is part of your assignment, so those application problems. Let's do the one, I think it's number 56 maybe, something about a painting in the format of Rubens, something about Rubens. I don't know if it's a guy named Ruben or Reuben Sandwich, but it has to do with some art stuff. So I think it says something like this. We got this painting. So here's the painting itself. And the painting itself has the width that is 3 more feet than the length. So when I'm talking about the painting, I'm talking about the width, and I'm talking about the width plus 3. Then it says it's framed up. So let's frame this sucker up. So we got this guy, and we buy a frame, and the frame goes around it like so. We're not answering that. And we can frame this thing up. Oh, bad frame. Bad frame. Bad frame. Let me get rid of that one. We go down here. We go over here. Okay. All right. Okay, I miraculously fixed my frame. Okay, so then it says that the frame is actually 12 inches wider all the way around. Now, since we're talking in feet here, and then they give us a area of the entire frame and picture as 208, we should get 1 foot here, 1 foot here, 1 foot here, 1 foot here. So really my new dimensions are W plus this foot and this foot gives me W plus 2. And then this way W plus 3, but I added a foot up and a foot down, so I get W plus 5. So we've got W plus 2 times W plus 5 is equal to 208 square feet. Now, if we're going to solve something like this, I got to FOIL that guy together. W squared plus 7W plus 10 equals 208. Move that guy over. W squared plus 7W minus 208 equals 0. You could solve by, hopefully by factoring. If the factoring doesn't work, you can always use the quadratic formula. Quadratic formula doesn't work, well, then you're probably out of luck. And I think if we check to see, whoops, I forgot to subtract. This should be 198, right? 198. So we ask ourselves, what do you multiply together to get negative 198 and add together to get 7? And your self answers back, well, I think 18 times 11 is 198. And if we subtract those two, we get 18 and minus 11. Check it out now. Negative 198, add together, negative 11. Set them both equal to 0 and solve. W is negative 18. W is positive 11. Does it make any sense to have a width of a painting as negative 18 feet? No, it doesn't. That's extraneous. W is going to be 11, and the W plus 3 will be 14. Those were the initial dimensions of the actual painting. The dimensions of the frame itself would be 13 by 16. So there you have it. You got one of the application problems done. There's a few others that are similar that you're going to need to work on. So now you can work on your 2-1 homework out of the book, and you should finish your 2-2 worksheet, and you should work on your 2-2 application problems, and you have a quiz on this the next time that you are in class on 2-1 and 2-2. Enjoy.